like we did with parabolic mirrors. What I really want to do in this video is just put objects at different distances relative to this convex lens and just think about what its image will look like. And the whole point of doing that is one, look, just going through all of the different situations, but more just getting practice of how to think about it. So let's first put an object out here that's more than 2 focal lengths away from the lens. So I'll put the object right here, and we'll just do our classic arrow. And actually, I'll make a point here. When we dealt with parabolic mirrors, we talked about the distance of 2 focal lengths being our center of curvature. Over here, we're just going to call it 2 focal lengths because it's really not the center of curvature of or this distance really isn't the radius of curvature of each of these curves. So we're just going to call it 2 focal lengths. So with that said, let's just actually try to figure out what the image of this thing will look like as the light from it gets refracted through this lens. So like always, it's useful to draw one ray. Remember, every point on this object is emitting rays in every direction because it's diffusely reflecting light. So what we do is we just pick rays that are convenient. So we could go from the tip of this arrow and go parallel to our principal axis, just like that. And I'm not going to show all of the internal refraction within this lens right here. But we know that if we enter the lens parallel to the principal axis, when we get refracted, we will go through the focal point on the other side of the lens. So we will go through the focal point on the other side of the lens. And we'll do the same. And now on the left side of the lens, we'll do another ray that goes through the focal point on the left side and then comes out parallel. So let's do that. I'll do that in another color. So it comes out. The incident ray goes through the left focal point, and when it gets refracted, it will now be parallel. It will now be parallel. And so the light that came from that point in the object will reconverge. I guess we could say it will converge right over here. And so if you did this for every point on this object, if you did a point in the middle right over here, it would reconverge right over here. If you did this point right over here, it would reconverge right over there. And so the image of this object is going to look like this. So it's going to be a real image. The rays actually converge here. So it is a real inverted image. It was pointing up before, now it's pointing down. And in this situation, it's actually going to be smaller than the original. It's a real smaller inverted image. Let's do a couple of other scenarios. I copy and pasted this before starting this video to save on time. So let's do a situation now where the object is at the 2 focal distances, I guess we could call it. So let's put the object right over here. I'll do it in blue this time. But we do the exact same thing. You might want to do it on paper on your own just to get some practice doing it. But we'll do one ray that is parallel, and when it's parallel, when it gets refracted, it will go through the focal point on the other side. And then we'll do another ray that goes through the focal point on the left side, and then it will become parallel. And they reconverge, or they converge right over there. And so you can see that this is actually a parallelogram. This distance right there is going to be the same thing as that distance over here. There's actually, I don't want to say symmetry. You can't flip it over. But and this distance right over here is going to be the same thing as this distance over here. I won't go into all of the geometry. But and if you did this with really straight lines, it would just come out that way. But this will just be an inverted image that's exactly the same size at the exact same distance. Actually, I didn't talk about distance in this one over here. Over here, it's a real image. It's smaller, and it's also going to be closer in than this one was. It's going to be closer to the lens. This is going to be really the same image, or the same size. The image is going to be the same size as the original object, but it's going to be inverted, but it's going to be at the same distance from the lens, just on the other side. And once again, this is a real image. Let's do another one. Let me copy and paste. So let's stick something between 1 focal length and 2 focal lengths. So let's put something right over. Let's put my object let's put my object right over there. So once again, let's go parallel. We go parallel, then we will refract through the focus on the other side. I can do a better job than that. We can go through the focus on the other side. And then let's go through the focus on the left side. And then we will refract and go parallel. And we will refract and go parallel. So here remember, I could do this with every point. I'm just doing it with the tip because I know the base will converge over there. If I just took 2 points, it would go converge right back there. And then if I did it with a point right over here, if I did that same exercise, it would go right over there. And so the whole image would show up over here. So here it's real, it's inverted, it is now larger, and it is now further away from the lens than the object, just on the other side. So this is really kind of the reverse of the first example. The first example, the object was large and more than 2 focal lengths away, and the image was in this range. Now the object is here, and now the image is on the other side. So they're kind of it's really just the other side of that first example. So let's do a couple more. Let's do a couple more. So let's put the object at the focal point. Let's put the object at the focal point. See what happens. And sometimes people memorize this type of things for physics exams or optics exams. You don't need to. All you have to do is remember, just think about 2 rays, usually from the tip of the arrow, because that gives you a sense of what the image will look like. And you do one parallel and one that goes through the focal point. And, well, with that said, we're going to do something slightly different when something is sitting at the focal point. When something is sitting at the focal point, one is we could do the parallel ray. So the parallel ray, it will be refracted through the focal point on the other side. And then instead of going something that doing a ray that goes through the focal point on this side, because it's actually you can't, you're sitting on the focal point right there. Let's do a ray that does not get refracted. And we did a similar thing with the parabolic mirrors. What I want to do is a ray, or actually with the parabolic mirrors, we did a ray that went right at the center. But over here, we'll go right to the center of the lens where it won't get refracted. So it's just going to go straight through. It's just going to go straight through the center of the lens. And so what you have here is both of these rays that were diverging from this point, from this tip, they don't reconverge anywhere. And they don't even look like they're diverging from another point. If someone's eyeball is right over here, they're just going to see these as 2 parallel rays of light. So no image will form, not a real image or a virtual image. So we can say no image is going to form. Now the last case is, let me draw this. I'm running out of space. Let me just paste it over here. So the last case, let's put the object less than 1 focal distance away. So let's put the object right over here and think about what happens. So once again, if a light ray from this tip were to go parallel, it will be refracted through the focal point on the other side. And then let's do another light ray, go in a direction as if it were coming from the direction of the focal point on this side. So if it were to come from that direction, the light ray would go like that. And then it would come out on the other side parallel. So it would come out on the other side parallel. So clearly, these 2 light rays are not converging, so no real image is going to form. But they do look like they're diverging from some point. They do look like they're diverging from, let me continue these lines. They both look like they're coming from a point. They look like they're coming from a point right over there. So what's going to happen? Well, if someone's eyes are processing these light rays, they're going to see the tip of this arrow all the way up here. They're going to see the base of this arrow. They're going to see the base of this arrow down here. And essentially what's going to happen is they're going to see a magnified version. They are going to see a magnified virtual image, I should say. They're going to see a magnified virtual image of the actual arrow. Anyway, hopefully you found that interesting.